In this lecture, we learn about EMR cluster, which is responsible for data processing. The central component of Amazon EMR is the cluster, a collection of Amazon EC2 instances, each known as a node with a specific role within the cluster. There are three node types. The primary node, which manages the cluster by coordinating data and task distribution, tracking task status, and monitoring cluster health. The core node, which runs tasks and stores data in the Hadoop Distributed File Systems, or HDFS. And the task node, which solely runs tasks without storing data in HDFS and is optional in a cluster. Every cluster has at least one primary node, and multi-node clusters include core nodes with task nodes added as needed. When you set up an EMR in your code, make sure to use instance fleet. Using an instance fleet configuration for Amazon EMR offers a strategic approach to achieve scalability and cost efficiency in the EMR cluster. Instance fleet setup allows the selection of multiple instance types and purchase options, including on-demand and spot instances, within a single fleet. By leveraging spot instances, which are more cost-effective than on-demand options, instance fleets help reduce costs while maintaining necessary computational power. Additionally, this configuration enables the automatic scaling of resources based on availability and demand in the region and availability zones, ensuring the cluster can efficiently handle various workloads. Prioritizing instance types and distributing them across different availability zones also enhances the cluster resilience, ensuring continuous operation even if some instances become unavailable. It is also important to choose the right instance type for EC2 instances for the EMR cluster. The instance type can be different depends on the workload and computation task, which could be compute optimized instance, memory optimized instance, general purpose, or storage optimized instances. Since this case study involves aggregating patient data from various sources and possibly handling large-scale data processing tasks, memory-optimized instances can help ensure that the processing runs efficiently without bottlenecks due to insufficient memory. The next recommendation is to break down the tasks to 4 or more steps, such as data cleaning, data verification, data transformation, data storage. The data processing workflow begins with data cleansing, where data is validated to meet quality standards such as completeness, accuracy, and consistency. This step includes standardizing data formats across various sources to create a unified structure and implementing error detection and correction mechanisms to address issues like missing values or outliers. Next, data transformation involves normalizing the dataset to ensure consistency, aggregating patient data by summarizing lab results or combining treatment histories, and filtering out any unnecessary or redundant data that doesn't contribute to the final analysis or reporting. Finally, in the data storage phase, the processed and transformed data is loaded into Amazon S3 or Amazon Redshift, partitioned for efficient querying and retrieval based on factors such as date, patient ID, or data type, to make the data accessible for analysis and reporting. Once the EMR job finishes the task, the EMR cluster gets terminated.